Alright, yeah, welcome to this video, and in this lesson we have been asked to check the continuity of this function and to see if it is continuous at x equals 2 for this piecewise function. And we call it piecewise function because the function, as you can see, is scattered into parts, that is into pieces. So the conditions are: the first condition is f of a of the function must be defined, and the second condition says that the limit of the function as the value approaches the right must be equal to the limit of the function as the value approaches the left. So what I'm trying to say is that the first condition says that f of a must be defined. Now let us pick any of these equations here and check if f of a is defined at x equals 2, because we know that a is equals 2. So f of a equals f of 2 equals, let us pick this expression here. We have x squared minus 1 equals to 2 squared minus 1 equals 2 squared is 4. 4 minus 1 is 3. So obviously this is defined. For this as well, it should be defined, because for every polynomial equation or function, the function is always defined. So let's go. The second says that the limit must exist. The limit as x approaches the value from the left of the function must be equal to the limit as x approaches the value from the right of the function. If these two are equal, then we can move to the third condition. So let's see. Let us find the limit as x approaches the value from the left. So the limit as x approaches to from the left of which function, of which one, this or this. Now you should know that if you are picking from the left, you mean that you are going to the left. These are number line, these are 2. You are going to the left of 2. So this arrow line, this arrow must indicate you are going to the left direction. So this is the same arrow line here. So because we have this, we have to pick this expression here. So we have x squared minus 1, which is 2 squared minus 1 will also give us 3 again. Now from the left we got 3. Now from the right, limit as x approaches a from the right of this function, right? Yes, because this arrow indicates the forward direction. So we have 3x minus 5, which is 3 into 2 minus 5. 3 times 2 is 6. 6 minus 5 is equal to 1. Now you see that this limit does not match. Yes, the limit does not match. Now because f of a is defined but the limit does not match, we call this a special kind of discontinuity, which is a jump discontinuity. And because of this, we can say that the limit as x approaches a of f of x does not match f of a, which is the third condition. The third says that this must match, but in this case it does not match. So this function is discontinuous and it is having a jump discontinuity. Why jump? Because the limit does not match. Thank you, and see you in the next video.